Welcome, everyone. Thank you for joining us for today's webinar, What to Know When Performing Hazardous Area Classifications, presented by David Weschler and Austin Thomas. Today's webinar is illustrative of our mission at Baker Risk to manage hazards and risks through high-value services, products, and research. At Baker Risk, we focus on 5 specific areas: incident investigation, loss prevention, testing and research, risk management, and the Baker Risk Learning Center. We invite you to visit our website to learn more about us. At our website, you will also be able to view and watch our previous webinars on demand. Now, for today's webinar, I want to go over a few housekeeping items. First, we have posted links to content related to our webinar subject in the chat box. We invite you to explore Baker Risk published papers, previous webinars, and Baker Risk Training Center courses related to hazardous area classification. Second, we want to respond to your questions following this webinar. Please type questions into the Q&A box, and the presenter will respond to the questions. Finally, at the close of our webinar today, please provide feedback by responding to our survey. Now, let me introduce our presenters, David Weschler and Austin Thomas. David is a principal engineer at Baker Risk and is located in our Houston office. David is the Baker Risk Hazardous Area Classification subject matter expert. He has been a continuous member of several professional committees, including NFAP, ISA, and IEEE. Austin is a project consultant at Baker Risk and is also located in our Houston office. Austin is experienced with several in-house Baker Risk software tools, including SafeSite, FireHat, and HackTool. Now, without further ado, I will turn the time over to David and Austin.
Thank you, Naomi. Welcome to the webinar, What to Know When Performing Hazardous Area Classifications. In today's webinar, I think we're going to focus on 4 specific areas that we'd like to stress and have you understand. The first of these is, what is HAC, which stands for Hazardous Area Classification, and why it is important. Secondly, we'll look at how to perform a hazardous area classification, looking at a unit boundary versus a point source approach. Third, we'll look at ignition gap analysis, which we'll get into a little more explanation further in the webinar. And lastly, we'll look at a comparison of the applicable industrial standards that are available. So the first question is, what is hazardous area classification? The main objective of hazardous area classification is to identify and classify areas around process equipment that handle flammable, combustible material in order to prevent fires and explosions. A good analogy is to look at the fire triangle on the right-hand side of this slide, where we're showing an ignition source, fuel, and oxygen. By having all 3 of these legs of the triangle stand, we will sustain a fuel ignition condition. And obviously, the goal is to prevent fires and explosions by addressing the elements of the fire triangle. The hazardous area work involves a number of codes and standards. Depending where you are in the world, you may see some of these. This is an example of several of them. They include, in the United States, OSHA, which is a government regulation. We have API, the American Petroleum Institute. We have the NEC and NFPA, which are both National Fire Protection Association documents. We have UL and ISA. In Canada, we have the Canadian Electrical Code. ATEX is what's generally being applied, similar to OSHA in Europe. Then we have IEC and SINELEC standards, which are standards and codes and guidelines that are utilized not only just in Europe, but in other areas of the world. It is very important to select the appropriate code or standard as the basis for this analysis, because while they contain a number of common areas, there are some differences. Above all these codes and standards require that the hazardous area classification be documented that it's current and it's reviewed. And we suggest it's reviewed as part of the MOC work process. As part of the reviews, I'd like to stress that it is important that the hazardous area classification be reviewed. You may ask yourself, well, why review this? I mean, if we have an existing plant and we've had this hazardous area classification or electrical area classification in practice for 30 years, why would we have to change? Well, the answer is there are changes that go around in the process areas. There's changes in the process equipment. There's changes in instrumentation and process control. There are other things that the plant may want to consider. Does what is the hazardous area classification being used for? So while the goal is to utilize the appropriate electrical design equipment, which meets the potential hazards of the material to reduce the potential ignition, again, it's important that the things be current and they be kept in a review mode so we are all of the same understanding as we move forward. As I mentioned, there are a number of regulations, codes, and standards that essentially have similar requirements. The text in red is an extract from one of these. And it's very important because what it states is locations shall be classified depending on the properties of the flammable gas, flammable liquid produced vapor, combustible liquid produced vapors, combustible dust, combustible or ignitable flyings that may be present, and the likelihood that a flammable or combustible concentration or quantity is present. You notice that the active words are properties of the flammable gas combustible materials. It's not a classification of the electricals, which is an old term that used to be utilized. So essentially, classification is based upon hazards, the hazards of those flammable materials which may be present in the area normally or abnormally. So why is hazardous area classification important? The objective is to prevent potential ignitable atmospheric conditions in air by requiring ignition source controls. The ignition source controls may include flammable gases or vapors. It may include combustible liquids, dust, or flyings. But again, the objective is to have the uncontrolled ignition of flammables in air, which can result in loss of life, property damage, or business interruption, as well as negative impact on communities and legal liabilities, be under control. That's what we are trying to do as the step points of the hazardous area classification. Now I'd like to ask Austin to explain a little bit about how to perform a hazardous area classification analysis.
Thanks, Dave. So yeah, as Dave mentioned, I'll be talking through the steps of how to perform a hazardous area classification. From an overall perspective, the traditional unit boundary paintbrush approach would classify an entire process unit to the boundary limits based on the materials present to the highest classification. So the example we're showing in the left is you have a typical hack contour where you have a simple rectangle that goes around the boundary limits of the unit, classifying it to the highest extent based on the materials that are present. Experience has shown us that this leads to increased capital costs without the corresponding risk reduction benefit. So what we'll be talking about in this presentation is a different approach. It's a point source scenario-based approach where we classify the process areas based on the actual equipment that's present and the appropriate extent and distances based on the hazards and materials present. So each individual piece of equipment will have its own contour, which we can then integrate to create a holistic overall classification contour. The scenario-based approach is a phased approach where we first have some steps to define our classified areas, and then once we have that model developed, we can identify potential gaps. So we'll be looking at plot plans, process flow diagrams to identify release cases and release sources, and then we can identify potential gaps for buildings and electrical equipment. So the first step is to review the plot plan. We're showing an example, a generic process unit on the right-hand side, and it's important to review the equipment layout diagrams to determine what kind of equipment is in the unit and where it is located. Our main concern is going to be equipment that handles flammable materials because those hazards are what are going to define your classification contours. The next step is to identify the release cases, release sources, and process streams. We will review the process flow diagrams and the heat and material balances to identify potential release cases and define those process conditions. So in this example on the left, we have an example process flow diagram, and each color around a different piece of equipment represents a different release case. So you'll have point sources and vessels for the heat exchangers, the distillation columns, the reflex drums, the pumps. All of these things will be individual point sources in the hack model. And then we can classify the streams based on the materials that are present. The next step, once we've reviewed the plot plan and the process flow diagrams to identify the sources, we can generate a 3D model with all of the equipment in the unit. So in this example on the right, all of the green vessels, squares, and point sources, these represent release cases where it represents the equipment in the unit. So these little cross hatches represent point sources for pump or compressor seals or control valves, and the larger rectangulars or represent the process equipment. And then we can assign the process streams to the relevant equipment based on the PFDs and heat material balances. After we've built the model and added in all of our sources, we can determine the extent distances based on the relevant code or standard that we're using for the study. So in this example, these two figures below are taken from NFPA 497 and show the examples to extent distances for different types of equipment. On the left, it's a process equipment that's handling flammable liquids located outdoors at grade. And you can see, based on the shading, which areas are going to be classified as Division 1 or Division 2 based on the materials present. Then lastly, this is your output. Once we've reviewed all of the equipment and identified the process streams and assigned them to the sources, each one will have its own individual contour, which we can then integrate to create the overall holistic contour. So instead of having the entire unit classified as a certain type based on whatever the most conservative approach is, by using the scenario-based approach, we can generate a model that will truly reflect what's in the unit. So that's the first few steps where we identify the classified areas, and for the gap analysis, I'll hand this back over to Dave.
Thank you, Austin. One of the things that we've have not addressed in the earlier slides was the question about what to do about buildings. Many of you may be aware of the fact that buildings may be located in hazardous locations. These buildings may take the form of control rooms where you have operating conditions going on to control the process. You may even have analyzer buildings where you actually have process streams entering into the building and having to address those set of conditions. You may also have motor control centers where it's desired in many cases to have a ventilation system that's going to temper the air and control the moisture and humidity contents to enable the electrical equipment to work reliably. And you may even have the new state-of-the-art buildings, which are called shelter in place, perhaps even a Baker Risk fortress building that you may be working on or looking at. In this particular slide, the intent is to cover as much as you can about the specific building. What are the design constructions? What's going on with it? Where is it located in the classified area? Perhaps maybe the building may need to be pressurized, which would apply the NFPA 496 example classification document. And does the building have any gas detection capabilities? The common thing with ventilation systems in the buildings is the fact that the building ventilation systems need air. And it's very important that the air be taken through air intake stacks that are coming from outside locations that are normally free of toxic or flammable gas concentrations. So these fresh air intakes are sitting out there, and they should be coming for what we call unclassified locations, which is a location that says the air is going to be relatively clean for use. So it's very important that you examine the building, what's happening with its ventilation system. Is that ventilation system appropriate for the hazardous area classification and for the desire of normally trying to maintain inside the building that you can use general purpose or unclassified electrical equipment within that building, regardless of what the interior of the building classification would be. Moving on, we're going to look at the ignition gap analysis. The ignition gap analysis is an important step because this takes the transition from moving from the actual modeled hack contours, which are those areas that we've defined as being areas that we want to use special equipment. And we want to verify that the equipment installed in those areas does in fact agree or is suitable for that defined hazardous area classification. The equipment in the field may be impacted by the type, its ratings of the equipment and mechanical integrity. And it's very important that we compare the equipment ratings to the hazardous area classifications shown. In this particular slide, this is showing some of the characteristics that you might want to consider when you're evaluating the electrical equipment. Again, not only are you looking at determining what the equipment is, but you want to make sure that the equipment is in good mechanical operating condition. These are examples of some electrical equipment: lighting fixtures, switches, explosion-proof enclosures, motors, and instrumentation. I point out that the enclosure in the middle, the explosion-proof enclosure with all the bolts around the periphery, is a very important piece of equipment that's used in many locations. Quite honestly, it's quite amazing that in many cases those bolts are not properly torqued or may not even be tight, and in which case that renders this box enclosure totally unprotected. So it's important that we record those things and make sure that the equipment is properly maintained. Once we've gone through these steps, then we can look and place the electrical equipment along with our hazardous area classification contours. And in these two figures on the left, you could see the plot plan with 2D, where the red circles indicate the ignition sources. The green are the process sources that we have observed earlier. The darker check boxes are the buildings that we've just talked about. Also, you'll notice on the right, we have what's called a 3D view. 3D are very valuable in the fact that they enable us to see what's happening when a release occurs. We know that releases just don't go along the ground. They may go up and they may go to the top of a column. And it may be important to know if I've got a very high column or processing condition, what the area classification is at the top of there. So we might pick the appropriate lighting or other equipment that might be needed to be used to comply with the hazardous area classification. So again, that's giving us a look at the 2D and the 3D. Most people have seen the 2D, but few probably go to the effort to generate a 3D picture, and it does have value. Let's now transition and look at the applicable codes and standards. And what I'd like to do is focus on the two basic methodologies. And to do this, I'd like to look at a comparison of the hazardous area classification for a storage tank. The two general methodologies are called a class division scheme versus a zone scheme. And if we look at the left side picture of a tank, we can see that the vapor space using the class division is showing that that vapor space is a division 1. Coming out of the vent on that tank is also division 1, and adjacent to that is division 2. If we're looking at the zone methodology, you can see we have a different set of conditions. On the right, the zone 0 is that now called that vapor space. The zone 1 is coming out of the vent, and the zone 2 is the area adjacent to that. So what you can see in this picture is there is a difference between division 1, zone 0, in some cases division 1 and zone 1. To look at these things with some text associated with that, I don't expect you to recall this, but just understand that the division 1 is the hazardous location of materials which exist continuously, intermittently, or periodically under normal operation or maintenance conditions. On the zone side, the zone 0 is the hazardous area in which flammable gas or materials is present continuously or frequently or for long periods of time. The zone 1, on the other hand, is a hazardous area in which flammable gas is occasionally present to be present during normal operation. The division 2 and the class division and the zone are somewhat similar. As you can see, they're both dealing with the materials normally confined in closed systems, but may escape only as a result of rupture or breakdown. So let's look at the benefit of performing a hazardous area classification analysis. Austin?
Yes, thanks, Dave. So some of the benefits of doing the hack using the scenario-based approach. In this example, we had a client where we're working on a project and they had some questions around their existing classification areas. They were using the traditional approach where the entire unit was considered a Class 1 Division 2 area. And in order to expand that unit or to install any new equipment, because it's entirely classified, the equipment has to be rated to meet that area. So when we went in and did the scenario-based approach to generate the quote unquote true contour based on the materials and equipment that is present, we found that the area where they wanted to install the new equipment was technically an unclassified location. So as I mentioned previously, using the traditional approach, our experience has shown leads to increased capital expenditures, and by using the scenario-based approach, we can define the overall contours based on the materials that are actually present in the units, which can lead to some cost savings. And another example we'll talk about using a hydrogen facility. As the world is looking to alternative energy sources, the principles of hazardous area classification can still be applied to a wide variety of industries. So in this example, we'll be talking about a green hydrogen facility where the production utilizes renewable energy to produce hydrogen from water via electrolysis. So you can see in the schematic to the right, we have a renewable energy source, in this case, wind, offshore wind, which is used to power the electrolysis process where we can generate hydrogen from water. And your primary concern from a hack perspective is which equipment that is in hydrogen service, that'll determine your classified areas. So as the hydrogen is being generated, compressed, and then stored, that equipment will need to be reviewed using hack and to ensure that you have suitable ignition controls in place for the equipment that's being used in that process.
Thank you, Austin. Let's take a look at some key takeaways and conclusions, if we may, from this webinar. First, our recommendation is that the scenario-based hazardous area classification approach provides a more accurate representation of a hack than the unit boundary assessment. As we pointed out, this allows a detailed understanding of what is involved with the actual hazardous area, both in terms of the materials and the electrical equipment and the processing equipment that's all involved with that. The unit boundary is just taking a very broad approach, and it's very difficult to determine what is the driver unless you're just doing very conservative approaches and not interested in the details. However, unfortunately, the details are very important, especially if you're looking at the life cycle of a production facility. Secondly, hazardous area classification is evergreen. By this we mean it's not a condition that you do it once, put it in your file cabinet and forget about it. Hazardous area classification is a very effective ignition control means, but it must be maintained currently. You have to make sure that the equipment is maintained, that your people understand why the equipment is installed the way it is, what they need to do if they find a piece of equipment that is defective, like I mentioned, the explosion-proof housing where the bolts are loose. Or they may find some other issues that may need to be examined as part of the process control and understanding of the procedures involved in running a safe plant. Item 3, hazardous area is a team effort. We say this because, as you can probably gather, there's many different elements that are involved with comprising the analysis for a hazardous area. First, you need people who understand what are the hazardous materials that are being used. Are they hazardous or are they not hazardous? What are the conditions of their operation? Secondly, you need people who are involved with the process. What is really going on with the process? Where are the areas that we're handling materials above their flash points or other areas that need to have special concerns? If we're using electrical equipment, and in most cases we are, we need to know what is that equipment that's being used. As most of you are aware, there are all kinds of motors, but not all motors are suitable for certain types of processing conditions. So you need somebody who has experience with the actual equipment that's installed. And lastly, I think you need somebody who's involved with training so that everybody can be up to speed with what exactly is entailed in the hazardous area classification. Lastly, the hazardous area is linked to technical safety. It's not an item that sits out there by itself. It's deeply related into other areas of work. For example, process hazard analysis, facility siting studies, and even quantitative risk assessments. All these are related to the hazardous area, and they need to be considered in totality as you move forward with your analysis. Having said all this, Baker Risk is available if we can help you. We can help identify and develop some practical risk refinements. We do have an experienced and integrated team of consultants, not only in the hazardous area classification, but in fire protection, hazard identification, risk control, and loss prevention. And we are able to leverage results from these other studies to perform, for example, fire and gas detection, fire hazard and mitigation studies, process hazard analysis, asset damage, and hazardous area, and many more things. In the context of this webinar, we have used some slides that have contained extracts from the Baker Risk software tool called the Hack tool. This is a very powerful documentation tool that, as you can have seen in the earlier slides, provides a capability for fully understanding what's going on and be able to drill down and understand what those conditions are. We expect to be able to license this out sometime in 2022. And if you are interested in the details of the hazardous area classification Hack tool software, we strongly recommend that you contact Baker Risk and follow up with us and express that interest so we can be in touch with you as we move forward with that. So thank you. We've gone through what to know when performing hazardous area classifications. And if there are questions, we'll be happy to try to address those now.
Thank you, David and Austin. I'm going to go ahead and ask some questions that did come up during the presentation. And just as a reminder to attendees, if you have not already done so, please be sure to type your questions into the Q&A box in your control panel. So, gentlemen, one of the first questions that came up was, what is the timeline expected to complete a hazardous area study as recommended in the webinar?
That's a very good question, and the answer is going to depend on the size of the study and how many things are going on. A large process could probably take, if it's a green plant, a new plant, may take longer than a already existing. But I would expect that you could probably look at anywhere from 2 to 3 months conservatively to gather all the information, put it together, understand what's happening, and then be able to define the hazardous area contours. Now, once you have the contours, the next part of the question is going to be, how do you know that the equipment installed is appropriate or suitable for those contours? And therefore, you'd have to understand what that equipment is, where it exists, and what the parameters of that equipment is. And that may be another detailed study. Generally speaking, for every point source, you may have 3 to 4 electrical ignition sources. So you can obviously appreciate the fact that as you go through this analysis, including the electricals, can add considerably to the overall work effort. but it is an important work effort so that you complete in an ignition gap study what's really going on within the facility that's being looked at. Thank you.
Perfect. Next question. Is hazardous area classification considered process safety or loss prevention?
In my opinion, it's both. I don't think it resides in one corner or the other, because if you look at typically what's going on, you're one aspect of loss prevention, for example, is you don't want to have fires. You want to control ignition sources. On the other side, on the process side, you want to make sure you're going to contain the process within the piping systems or vessels and not have it escape. And if it does escape, you don't want to have ignition. So I would say it would involve both parties equally and should involve both people and others to help with the assessment.
Great. In the case of installations with open and interconnected buildings, for example, in the tropical zone where there are no climatic seasons, how can an adequate separation of the different areas be made so as not to fall into the error of having the whole installation classified?
That is an excellent question because it's going to be highly dependent on what the process is, what's going on. Ventilation, if we're an indoor building, could be very important as to what is happening with that area, as well as conditions of housekeeping, control of spills and releases, what the area of the common area is between those two areas, whether it's between building and building or building and outdoors, and what's happening there. I don't think there's a really quick answer that I can say, just do one thing, but it would involve a study to really understand the process, what's going on in the processing condition, what the process materials are, and how the ventilation system interacts with it. So for example, if you're dealing with a combustible dust and you could locate the combustible dust areas of potential release in one far removed area of that building, that may have less of an impact. It's the conduit area between the two buildings a farther distance away. However, if it's a flammable liquid or combustible liquid source, which could spill and it could move to that other location through the common breezeway area, that represents a different set of conditions. So I think it's important that you consider those conditions as the merits of each and come to an appropriate conclusion. And again, if you need help, Baker Risk can probably help you with that.
Excellent. Next question. When Baker Risk prepares a facility siting study, they typically use leak sizes of 1/2 inch, 2 inch, and 6 inch, so the flammable endpoint can be a very, very long distance. For scenario-based hack, the leak size is typically very small. Can you comment on a potential discrepancy between facility siting studies and hack?
Well, I would say there's not a discrepancy other than the fact they're looking at different objectives. If you recall, when we went through the earlier slides, we mentioned that the purpose of the hazardous area classification was to control ignition sources within defined source conditions. We are not looking at classifying the world, but rather we're looking at localized control and seeing what are the things we can control that are in immediate control. So for example, if we have a process and we determine that the process leakage coming out into the air is unlikely under normal conditions, but it could happen, then we might have a localized leak as opposed to a condition that we say we are leaking material all the time and it's all over the place. That may have a larger extent distance. But again, for the scenario based upon how far can the process leak or release go, then you're looking at a different qualification. You're looking at what is the impact of the leak on societal, on operations, on adjacent properties, and other things. So I think you can appreciate the objectives are slightly different. Clearly, the hazardous area can control the ignition sources, but again, if you have a highway near your plant and it's 1,000 feet away, the hazardous area classification will not likely address that truck or that vehicle on that highway, but the site scenarios would do that. So it's a question of evaluating your overall risk, and this comes down to the overall evaluation of a site facility or risk for your plant and operation. So they are different. There have been attempts, I will point out, where some people have tried to utilize dispersion modeling for hazardous area classifications. My experience with that has often been that they pick a size of a hole that's very, very small, and therefore the footprint from the leak is very small, and therefore they would try to use a classification that's not as large as what we have applying codes and standards. Now, clearly this can be done if you're going to document things clearly and define why you're varying from standards and codes. But that's why I pointed out it's very important, excuse me, that when you apply the code and standards, you pick the one that's applicable to your particular application. So if you're a distillation or a petroleum plant, you probably would want to use an API code rather than the NFPA 497 code. But again, it just depends. So again, choosing the appropriate criteria is going to help in making sure your base conditions are well established.
Thank you for that. Does HAC have any impact on roadways should they overlap?
If we assume that the roadways are not public roadways, but they're inside the plant boundaries, I would say yes, they do. Because we know if we have a source near a road, that just because the road's there doesn't mean that the source or the footprint of that hazardous area classification will end at the road. It may go right across that road into the adjacent unit. It may also go across the fence line to the adjacent processing plant or other area. If you have a condition where the hazardous area is going into the roadway, that's a condition that you may want to think about and look at. An example of that type of condition might include areas where we have screened in or fenced in areas where you have control points for pipeline areas. These are sometimes on leased land where we have a fence around it, and we don't know what's going on beyond the fence line, but we generally stop the hazardous area classification at the fence line because in some cases we assume that's the limit of what we want to deal with. I would suggest that we need to look beyond that fence line and see what's happening, and if nothing else, take appropriate actions to define what that risk might be. Perhaps it may be if it's a highway or something of that nature, we may have to put gas detectors there to shut down the highway, just to look at that scenario. Not that that's the most ideal, but that may be something that may have to be looked at.
How often should the hazardous area classification study be updated?
There is criteria out there to address this. Some say annually, some say quarterly. My recommendation is that it is done every time you have a management of change process, that the management of change process should include an evaluation of what's going on in that area. You may also want to do a hazardous area classification evaluation when you do a condition where you're looking at a means of control, such as a hazard condition list or a change of work that's going out there, like a special hazard like welding on pipe or something of that nature. But again, I would say I'd like to see it done at least annually. I would prefer quarterly, but most definitely every time you do a management of change process.
Great. And this will be the last question before we conclude this presentation. Does Baker Risk offer HAC tool for purchase?
As I pointed out, there is a movement, and we are working on releasing the HACS tool software later next year. And I would encourage you, if you are interested in that you let Baker Risk know of your interest, and we'll be more than happy to contact you once that becomes finalized, and we can give you all the details that are needed that will deal with software licensing and support for that and anything else. So please keep us advised of what we can do to help, either through the software or by contacting Austin or myself or Baker Risk to address some of your questions. We know that the hazardous area work around the world is sometimes stressful, There are a number of codes and standards that you'll have to deal with. It's not a simple task, but we are here to help you as best we can. So on behalf of Austin and I, thank you so much for participating in our webathon today. Have a safe day.
Great. Thank you, everyone.
Sorry to jump in here, but Baker Risk has also developed a best practices guidance document that addresses many of the elements that we talked about today, but it will be an overview of what constitutes a best practice in industry for performing hazardous area classification, and that guidance document will be issued later this month.
Perfect. Thank you so much, Austin. Everybody, we thank you for joining us today. If you have any additional questions, we ask that you reach out to David and Austin directly. We appreciate you joining again, and we'll be kicking off our client collaboration series beginning February 2022 with Baker Risk and Southern Comfort discussing blast-resistant tent structures. You will not want to miss that. As a final reminder, today's webinar will be posted to the Baker Risk website. Thanks again, and we'll see you next time.